Morning, everybody. A super intelligence, hyper intelligence, or superhuman intelligence is a hypothetical concept of an agent who possesses intelligence far surpassing that of the brightest and most gifted human minds. Some look at this concept as the road leading to what is called as a true technological singularity, which is a hypothesis that the invention of artificial intelligence will abruptly trigger technological growth, unfathomable changes to human civilization, and some kind of a upgradable intelligent agent creating a runaway reaction of self-improvement cycles and whatnot. Right? Well, that kind of a possibility is still a little bit far away. It's definitely not an immediate reality, but today, as we stand in terms of what's happening around across industries in the sphere of technology, artificial intelligence is an area that we cannot ignore. There is artificial intelligence in many facets already, whether we realize it or not. But what we decided was, let's take the first step inside Abbott to galvanize the concept of artificial intelligence across functions, across verticals, in our sales and marketing, in support teams and so on. And this is the first small attempt in doing that. We have a very impressive array of speakers, despite this being a fledgling organization when it comes to taking up artificial intelligence. So without further ado, I will call upon Javed to kindly come up, declare this workshop open, and also share a few words in terms of encouraging us towards the journey of adopting artificial intelligence in Abbott.
So I was asked to come down and open the workshop for you, and I thought it was absolutely a brilliant session that I would love to sort of give out a few messages of how I see this workshop. Obviously, it's been first of all I would like to thank Deepak and the team for organizing this whole thing up for you, all of you.
I'm assuming that will be more people to see the back would also get to that, but then they're going to miss out something. I know. In this study, during the reading of the paper, Sundar Pichai, from Google,
Indian-born CEO, right, of Google. I mean, he mentioned something about AI, right? And according to him, what he says is that look, artificial intelligence is never going to replace human intelligence. It's by and large going to always be, it's going to augment human intelligence. And I think that's really the theme that we should, we should feel very, very comfortable. That's a very heartening and a very comfortable statement coming in from a leader, right? I mean, a company like Google, how they see artificial intelligence, machine learning, big data. So,
to me, I think, in many aspects, our extremely good. We all like to use it rather than we're hoping real great for across people that, hey, I'm there, I big data, and I know all these three terminologies, and that's enough, for me. And I think that's where we need to is beyond in terms of demystifying the whole concept of artificial intelligence. And already, you can see that in many ways we are already using it some way or the other, or we are just kind of, on the verge of using it, or we are just simply, slightly, many of us are technologically sometimes, we're just slightly afraid of taking that plunge and saying, hey, let me use Siri, for example, on my phone. Even though we're all aware of phone and there would be an artificial assistant there, but we generally tend to still go the old way. And I think that's really that quantum jump in mindset that we need to make if we want to really bring this not only for ourselves, but also we know that this is going to be of immense value for us, for our customers, for ourselves. So I'll talk a little bit about where I would like to go to that emphasis at Abbott. Obviously you've had it's great to see that at Abbott we have made a kind of a big jump, I would say, in that area with building of the Maya, the virtual assistant for the EPD field force, which I'm told that has now already been launched out at a national scale, right? Yeah. That's fantastic. And I think today, what I was also impressed by was the success rate of was I was told that there is a 60% success rate in terms of the assistant able to really
tell you exactly whatever you asked and you got the right answer, kind of a thing. And that's the feedback coming in from the Salesforce themselves, So imagine, really, impressive from that point of view. And I think, if you think back, many times, if you ever, especially, I find this a lot that, if you have to go to embassies and, you wish that these guys, rather than to be if you try and call them or something like that, forget about it. You could be waiting there for 24 hours and probably no one is going to even direct your call or they'll pick it up. But you wish that, if they had simplified things in which I could just get the information that I really needed, I'm not looking at talking to anybody, right? I don't want to talk to anybody. I would rather prefer if this information that I'm really pinpoint information would just be made available to me at an instant, and so that I am more efficient and productive and I can move on.
Doing whatever I need to. And just simple things like that. So you can see the possibility of permeating this permeating throughout the ecosystem. It's going to be an immense improvement in productivity. Yeah, I would say.
Hey, human frustration also has a value, right? No, we all agree. It will also bring down a little bit of our frustration. So as I move forward, all I would just like to tell you is that I think you should look at artificial intelligence in Abbott for one of the very major reasons that I believe is that we can really change is the whole area of how we connect up with our interactions with our medical practitioners. And what do I mean by that? I think you all know that if you think in terms of the number of doctors, in India, right? And we are all talking about Ayushman Bharat, how we want to see, healthcare penetration increasing, the government wanting to do things and whatnot. But guess what is the rate limiting factor over there? It is the availability of trained medical personnel.
It is the availability of doctors, the availability of nursing staff, paramedical staff out there. So despite all the goodwill of whatever you want to do, to increase the number of these staff suddenly is not going to happen overnight. It's going to be a huge journey, right? But then, how can we make them more? How can we make our interactions, or how can we make them more productive? And that's where I think we really come in, right? In terms of if we can use artificial intelligence, to be able to sort of improve their productivity, they will be able to see more number of patients correctly. If we are able to build in treatment algorithms for them, helping them, a company like us, which is our major player in the world of diagnostics and instrumentation, where we are able to collect immense amounts of data if we really want to, and we can use that data to be able to put together not only I would say much more accurate and timely and point of care diagnosis, but at the same time we can put together treatment algorithms for these doctors, and their patients are going to be, they will be able to write out a prescription, they will be able to together with diagnostics as well as with rapid diagnostics and together with artificial intelligence, they would be able to sort of reach out to and see much more number of patients that they are possibly doing. So we actually have that. If we can work together with them, we can really actually change the paradigm of how the patient flow happens in a private clinic, in a small clinic, or even in a large hospital. That's the possibilities that this project can do for us. The other piece, of course, is that in terms of able to patient education is again a very, very key element, right? How can we use artificial intelligence to really again educate patients on diseases, etc. Because we know also just again one data point is that any disease you take in India today, the treatment rates, the compliance rate of medications is less than 50%, even in well-to-do population. So, for example, if I'm suffering from diabetes today, and I've been asked by the doctor and I've been prescribed to take X number of diabetic products, anti-diabetic products, I will most probably stop taking it within 4 to 5 months. That's what data tells you. So imagine and the doctor tells you that you are taking for life, right? So that's, and obviously what happens when you stop taking this drug, your disease state obviously starts to worsen, and you go back again once things have really deteriorated further. So what we really need to do also is in terms of, there's immense value in patient education out there, to just simply, similar goal of improving the compliance of medications. If we can do that, that will be, you can imagine, forget about, our own sort of internal sales, etc. But I mean, we should be thinking in terms of patient disease, right? How much, better off the patient will population. And the last one is, of course, not ignore ourselves from internal education of ourselves. How can we use our treatments for that purpose? How can we educate ourselves on the fly, for the whole day? We are all busy people, and we're going to get busier as we move along. The demands on you on your work are so, are tremendous. And I appreciate that. And this is the way the world is going. But it does not mean that we sacrifice the time that we always keep for education. That's the one should be sacrificed all the time. We need to find ways. So how can we are able to educate our own people in a much swifter, faster way, and with the same rigor per se. And I think lastly, I'll just close with saying that this particular technology, unlike many of the other technologies that are coming around, it has a tremendous return. What do I mean by that? I'm simply saying that with only a small amount of investment, you can make a tremendous amount of change. And that's really not there with all technologies. So I would say that in terms of both return on investments as well as speed of innovation. So if you can combine these two together, if you think about it, I get a great ROI, I get a great speed hit. This is absolutely paramount as far as what the new technology is able to give us in this area. So I wish you all the very best for the day. I know that you're going to learn a lot today, and I'm absolutely sure that post that you will all contribute towards and come up with ideas which we can then focus and work up and build on and work in the next coming 12 months. Yeah, thank you so much.
Our first speaker of the day is a very esteemed person. He's a professor at the Department of Computer Science and Engineering at IIT Madras. He is known as the wizard of artificial intelligence. He is one of the most published professors in that space from India. He is also India's foremost reinforcement learning expert. Sorry, Professor, the T is a reinforced learning. We learned later it's reinforcement learning, right? So, please join your hands together to welcome Professor Ravindran Balraman. How we can look at implementing these in our partnership.
So can people at the back hear me if I move away from the mics?
Yeah.
that podium. I don't want to stand there, and I like to move around when I talk. As long as you can hear me. Does the person filming me need me to talk into the mic?
No, we can hear you.
Okay, great, nice. So let's start. So the goal of my talk is to get people excited about AI. I'm not going to do a dive deep into AI or anything. There's no technology, no equations. Right? The presentation will all be in English, don't Greek or Latin. And it's going to be a generic presentation. It's also not tailored. Just feel free to stop, ask questions, or ask me questions again. And so we also have a interdisciplinary center for data science and AI. If there is time at the end, I will tell you much about that. So what is the recent excitement in AI? So what is that? This is a headline. It is the entry of electronic computer today that expects to be able to walk, talk, see, write, introduce itself, and be conscious of its existence. Amazing. You guys all saw that today? At least saw it in July. Right? So AI has been around for a while. There is a lot of excitement. There's an actual headline from back in 1958, not today, and not this year. Right? So you have always been excited about AI. Right? It somehow seems like this seductive thing. It makes us feel like we are creators, rivaling. Yes, okay. But we feel excited about it. So why again now? Does that look familiar? If it doesn't look familiar, you haven't looked at the handouts that were given to you today. Right? I just saw that, I couldn't resist it, so I took a picture of the handout and then put it up there on the slide. So remarkably like the headline you saw a couple of slides back. Right? So why again all this excitement now? So it all started back in 2006 with this advent of this technology called deep learning. So what they did was they entered this competition called ImageNet. The ImageNet challenge essentially had a lot of pictures, and it expected you to put it into one of those categories. But it turns out that back then, back 15 years back ago, computer vision was considered a very, very hard problem. Right? Computers are really bad at trying to understand images, even simple things like finding faces in the image, finding out which is a human face versus a non-human face, and these things are actually very hard for computers. Right? And then there's this architecture called AlexNet, the AI agent of AlexNet, that came in and trapped the error that the previous year's champions were making. Wow, that's an amazing performance from the computer system. We never expected us to reduce the error to 16%. And then these images are not all that clear and clean, and even humans have a base error rate of about 5%. And then what happened after that? Year on year, right, AI agents started improving the error rates. It started from 16, went to 15 the next year, 7 the next year, 6.7 the next year, and 3.6 a few years back. Right? Now what is amazing about 3.6? It's better than humans. So we managed to get superhuman performance using AI on something that was considered a quintessentially human problem to solve, right? The problem of vision. So this is what gives all this excitement. And so before I pursue the hype further, let's step back, right, and give you a little bit of introduction into what is it that machine learning is actually trying to do, right? And so all of this, of course, this is not just pure AI. It's advances are possible because you are learning from data. So that's what machine learning is all about. Learning functions from the input to the output, right? But not because of rules that people write down, right? But learning it just from data. Right? So what do I mean by learning from data? So I'll give you all the historic, let's say, credit card transactions, and I'll tell you whether they were legal transactions or not. Right? Just that. Just the raw dump of data and whether they were tagged as legal or not. Or I can give you a whole bunch of customer data, whether they bought the computer or not. So from this historic data, what I expect you to do is predict from unseen data. When the new data comes in, I want to be able to predict whether it is fraudulent transaction or whether the customer going to buy my product or not. Right? This essentially the idea here is uncovering market. That's essentially what it is. And this has had wide-ranging impact. And so what are the different things you can do? I already talked about transaction fraud detection. So it's not just from credit card. Now people are looking at ATM transactions, and people are looking at stock, purchase, selling decisions. So any kind of transaction data, it's huge volumes of things. And what is amazing thing is transaction data is by and large digitized. Right? So getting your hands on that data is also easy. And people do a lot of work on that. Another area where people do a lot of work is on tracking customer sentiment and how are the customers liking your product, which aspect of your product do they like, and so on and so forth. It's just not just like and not like, but you can start looking at more fine-grained analysis called opinion mining. And of course, there's this whole thing on buzz analysis. Like what is hot right now? Of course, AI is hot. Other than AI, what else is hot now? Right? So can we do that from just looking at the online buzz? So there's a lot of work happens in that space. And so I had a bunch of other examples here. As you were talking, I quickly changed some of those. So looking at time series predictions, right? So you can do things like, okay, I looked at the person's history over time, and then I can predict how likely is he to take the next person. In fact, these are problems that people are actually working on. I think these are not hypothetical examples I made up on the slide, but these are things that people are actually working on. There are personal apps, right, that track you, right, and then essentially when interventions are needed, right, and they can actually pop up appropriate interventions or alarms and so on and so forth, right. And what's the gap till the next consult? Right, those kinds of predictions can actually be made even now with the kind of data that's being gathered. And of course, people do a lot of work in using machine learning in risk factor analysis. What are the factors that are most contributing to the operation of the system? Right? And especially in kind of medical diagnosis. I have like so many different factors that a patient comes in with, which is the most likely risk factor that I should be watching out for. And there's an interesting study people did a couple of years back at the Wake Forest Hospital in Virginia. Right? So what they did, not separate. It's on the bottom, it's on the other side. So what they did was they looked at historic data, right, the longitudinal data of heart disease incidence, and then they came up with something very interesting. So if you're a smoker in your teens, it doesn't matter how much you change your lifestyle later, your heart attack risk goes up. This is something which doctors apparently had suspected for a long time. But to actually tease it out and then show using machine learning techniques that this is a real risk factor was very much welcomed by the doctors. In fact, that study had got a lot of buzz both in the machine learning circle as well as in the medical circle. So a lot of work that has been done there, right? And of course, you can look at a whole bunch of other things. So there's a difference between this and this. So the first slide was all about what is called supervised learning, where a human has already looked at the past data, has curated it, and is telling you, okay, what is right and what is wrong, and you are learning patterns from that. And all the applications on this slide are when no human actually has looked at it. You just have historic data, and you are trying to find patterns in historic data. You have not had any human annotations of this data. Right? So you can look at segmentation of customers. You can look at by purchasing behavior or look at demographic, and so on and so forth, and you can learn patterns. And you can do what is called anomaly detection. So you're looking at a person's behavior. This is something that a problem that we worked on with a couple of organizations. Where we have the normal activity, monitoring the normal activity of a human being in the house, like an elderly patient. And then you want to know if this is a normal delay for the person to move from one task to another, or has the person fainted or fallen down, injured. This is an abnormal delay. Should I call for the intervention by a caregiver? Right? So for you to be able to predict that, right? So you have to model what is normal and then go back to looking at what is abnormal. Right? And you can look at all kinds of documentation and figure out if there are new topics that are emerging in the discussions that are coming up, and those kinds of studies can also be done. And of course, a lot of work is done with biological data, especially in systems biology and bioinformatics. Huge amounts of applications of machine learning has happened, and we have a very strong systems biology group at IIT Madras. And quite a bit of work in genomics, proteomics, and related areas. And of course, we also can look at what are called causal analysis. So I look at the evolution of a system and I can figure out what are the trigger events, what causes what. So you could look at that in terms of, I mean, we are looking at it in terms of engineering systems, but you can also look at it from medical phenomena. So that's also possible. But the wide variety of applications, the possibilities are endless. But the idea behind it, right, the crux behind it is something very simple. Right? So I'll just illustrate that with this we call spam. So you were mentioning that people have already interacted with AI. Anyone uses an email system, right, interacts with AI. It doesn't matter. It doesn't even have to be Gmail. It could be your enterprise email server. If it has a spam classifier in there, it's using AI. Right? And so the idea here is, given an email, right, I want to be able to say whether it is spam or non-spam. And so the way, so this is essentially a target. Right? So what email to go into a model, it has to spit out spam or non-spam. And what do I have? Right, I have a lot of emails from the past. And some human editor or yourself, and you move things into folders, have labeled them as spam or not spam. Right? This doesn't look like a typical mailbox, right? Typical mailbox, most of the mail will be spam, and one or two will be not spam. But for some reason, the labels are here. But anyway, so what I do is I feed it into a learning algorithm, right? And outputs a model. And what does the learning algorithm do? It essentially tries to find some rule here, which I call it H, that takes my email and maps it to +1 or -1. So +1 means it's spam, -1 means it's not spam. That's all it's doing. And what kind of a hedge do I find? I find a hedge that says that the fraction of examples on which I make a mistake in the training data or the test data is increased. That's it. So from that simple idea, right, how did we get to superhuman performance? It's exactly the same thing that happened here. I gave you this set of images, I gave you the labels. Right? So instead of spam or not spam, I'll have like 15 categories or 10 categories. Instead of +1 and -1, I'll be outputting 1, 2, 3, 4, 5, 6 after 10. So how did I get from that simple idea to superhuman performance? So it all started out in 2006. So this is my homage to the people who made this happen. Right? So critically, these are the three things that are responsible for this. So we have more data. I believe, I know that there are some domains where data itself is a challenge, but by and large, we have more data. Right? So when I was a grad student, when they said we have a large data set, it meant it had 100 entries. So nowadays, 100 entries is not even enough for you to teach a course. For first introduction to machine learning, I'll give data sets with 100,000 entries, not 100. So it means we have more data, more than what it used to be earlier. And of course, a lot of aspects of modern life is digitized. Everything is online. But still, more importantly, there are new methods and algorithms, new insights into how that that optimization problem I was telling you about, how that operates. And newer methods that allow you to find solutions where there were more than 1 million variables. Now, I'm not talking about tens of variables to solve for. I'm talking about millions of variables to solve for. And when I have these kind of millions of variables, mostly it's just not the compute alone that is going to help. I can throw more and more powerful computers at it, but if my algorithm is inefficient for millions of variables, all the compute in the world is not going to help. So this was very crucial. So and these three people are important in coming up with many of those insights. And Yoshua Bengio, who's still an academician at Montreal, and Jan LeCun, who heads Facebook research now, but started out as a professor at New York University. And Jeff Hinton, who started out at University of Toronto, and now heads Google Drive. So all these people are actually pushing the frontiers of research, both from academia and industry. And of course, these are all the people in North America. There was another person in Europe, Schulthuber, who's still in Zurich, who also contributed a lot. So these people came up with this new insights, methods, and algorithms. But supporting them at the same time, there are also these advances in computer architecture, storage, and also compute. Right? So you have GPUs, and then you have all this very fast parallel processing engine, and that allow you to build industry scale successful. These are not one-off, academicians publishing papers in top journals and conferences, but actual products that are going out into
Apple is not Apple
So Apple typically ends up making things for Apple products. So that's the reason it's not there. I mean, these guys, well, of course, Facebook is kind of there. I would say Apple is not there because Apple is not very open. So these guys are more open about what they're doing, and so Apple does use a lot of AI. In fact, Apple kind of missed the bus because they were first on board with the speech engine, Siri, but Siri was not deep learning. Version 1.4 of Siri was not deep learning. They were way ahead of the rest of the field in getting non-deep approaches to AI to work. But then when deep learning became successful, kind of was like an order of magnitude better performance than Siri. But Apple was little, there's this inertia. Oh, we have a successful product, why throw it away? Now Siri is deep learning, but they came a little late onto the scene. So Cortana and Alexa and all these guys. Amazon should be there more than Apple. Cortana and Alexa, all these guys have actually picked up big time. Siri is now playing catch. But that's the most significant success story for Apple. While these guys have a lot more other and Amazon. Maybe the next iteration I'll add Amazon. So much so that now we are able to do things which we wouldn't have thought computers capable of, right? Creatively, in some sense. So give it an outline like that. How did this happen? It was trained with a lot of examples of impressionist painting, right? And then when given a outline like this, managed to produce something. Now look at this. So given a black and white picture, it colorizes it.
Google Lens.
Yeah. So that's whosoever did it. I'm not making sales pitches here. Whosoever did it, the technology is there, right? So it's amazing. Right? And look at this. So you give it a color scheme and give it a picture. It somehow adapts it to this, right? Figures out which parts of it is more appropriate for this. And this, I would call this creativity. But it's just a neural network trained using supervised learning, just like I showed you the spam classifier. Okay? This is amazing. And we got to a point where there is an annual deep learning art competition. It's art exhibition. So they do this every year in this conference. There is one whole day, and people put up artwork. Okay? And then people go around, vote for it, and then they elect a winner and stuff like that. But some of those artwork that they put up is really amazing. You wouldn't believe that there is not a human brain in it. And of course, you can do other things. Right? So look at that. Person riding a motorcycle on a dirt road. You can't get more accurate than that describing that image. Okay? And that was generated by a deep neural network. Of course, we are all not there yet because we have not solved the problem. Otherwise, look at the little pig girl in a pink hat. Okay, so far, blowing bubbles. The girl is pouting a little bit. Maybe that got interpreted as blowing bubbles, but still it's not. We wouldn't mistake it for blowing bubbles. But still the picture is. So there are other impressive progress in our game. One is in speech recognition. The black line is human error rate. Right? When we hear somebody speak and then we try to write down what they said, human error rate is human accuracy is that, not error rate. Sorry. It's about 95%. And then the automatic speech recognition system, which are, you can see this quantum leap here. It started when people figured out how to get deep learning for speech recognition. And now we are better than human accuracy when it comes to speech. It's amazing. As little as 10 years ago. We were way behind. And now we have all this speech synthesizer, speech recognizer, So much so that the voice searches is growing faster than the keyword, faster rate than the keyword searches. And they expect by 2050 or so that our interactions with computers will largely be through voice recognition. So it is changing. You are planning, but it's not changing, but it is changing. The data says that things are changing. So more recently, there must have all the AI excitement started again with all this thing about AlphaGo beating humans, the best human player. So I should tell you a little bit about the game Go. So it's a very, very challenging game. It's played on a 15 by 15 board and a lot of pieces on it. What makes it challenging is the following. So let's say a game like chess. Right? At every position, you have like an average of 35 possible moves that you can look at it. 35 possible things that you can do, and then you can look at those, consider it, and then go ahead. Right? But something like Go, you have 250 possible things you can do on average when you look at a board. So for humans itself, it's a huge challenge. Right? So the tagline for Go is a minute to learn, a lifetime to master. Right? So Go rules are very simple, but then the kind of combinations it opens up are many. Right? For computers, it has always been one of those final frontiers. If you can solve this, then you have really understood intelligence or something like that. So we have solved it, but I don't think we have really understood it. But shows you how little we knew about it. So this is a story about when the company called DeepMind, when they set up to challenge this guy Lee Sedol, was widely considered as one of the strongest players of Go. Right? When they set up to challenge Lee Sedol, they put out press statements like, oh, we'll be happy if you win one game against Lee, and we don't want to put up don't want to mess up completely and things like that. They're making all this good PR noises, right? Making sure that they were CIA. Then they started playing, and in the fourth game of the match rolled around, people were surprised that Lee Sedol won one game against AlphaGo. Right? Because AlphaGo was playing so well in the first three games that a human winning one game against it was considered a surprise. Right? And then, of course, AlphaGo went and trained a little bit more, and then came back and beat Lee Sedol the next game. But the point was, AlphaGo had millions of games to learn. Right? Lee Sedol had 3 games to learn, and he managed to beat him in the fourth game. And to Lee Sedol's credit, he's the last human being to beat AlphaGo. So after that, every other game AlphaGo has played, he has won 5 games against humans. And then there's the other thing that happened. Go is so simple. We have only like 2 kinds of pieces, and so on and so forth. And that's play strategy games like humans play, like Age of Empires or Defense of the Ancients and things like that. There are many different types of players and lot of objectives and so on and so forth. And again, OpenAI came up with a player that managed to beat humans in tournament game. And so again, this created a lot of hype, and of course, this is Elon Musk, hype master extraordinaire. Right? So he talks about vastly more complex and traditional board games like chess and Go, but he's right. So what was this that caused this last 2 bits of change where you are getting not just superhuman performance, where machines are like literally wiping the floor with it. Not just superhuman performance, but outwardly performance. In fact, Go is like a religion in a lot of Far Eastern countries, and there are people who do commentary, just like there are cricket commentators, there are Go commentators and things like that. There's one Go commentator who wrote about the AlphaGo, the third game in AlphaGo, Lee Sedol challenge, and he said, for the first time in my life, I felt like I was watching an alien intelligence in operation. Because I could not understand any of the moves that the agent was making when I was watching the game. And after it won, I go back and analyze, I see what was the point of those moves. But when I was watching it, I had no clue what it was trying to do. What allows us to transcend human intelligence in that kind of a level? It's something called reinforcement learning. So I have to pick it. So the disclosure, I have been doing reinforcement learning since '95. I didn't get on the reinforcement bandwagon recently. So I'm happy that reinforcement learning finally is getting its due. So all these models of applications I have spoken to you before, right? All of them learn from data, whether it's human annotator or some kind of human involvement in generating the data. Here's the usual question for introducing reinforcement learning. How did you learn to cycle? All of you learn to cycle. How did you learn to cycle? Was it from data? Did you watch thousands of hours of YouTube videos and then get on the cycle and go? No. Did somebody give you instructions on how to cycle? Not really. What would I have said? Go slow. Somebody or something like that. Yeah, keep pedaling. Right? We watch out, and then if you fall down, you get hurt, and then it pains, and then you get some feedback. Or if you actually do well, and then somebody claps and says, great, right? So that's the kind of feedback you get. It's essentially just non-instruction. You do stuff, and then somebody evaluates it. Either the world evaluates it because it hurts you, right? Or a parent claps, right? Or parent shouts, whatever it is, right? So that is the evaluation you are getting when a kid is learning to cycle. You don't get instructions, you get evaluation. So it is trial and error. So you have to do something, otherwise you are not going to learn. So this is the crux of how you learn to cycle, and a lot of things actually are more naturally modeled like this than having a human give you instruction. So how did Go player became so good? He learned to play against itself. No human was giving instruction. It did trial and error. Right? It played millions of games. It did all kinds of nonsense at the beginning, right? And then slowly it improved. How did the Dota player play? Right? Because he didn't have any games. Right? For 2 weeks, we were just using Thursday play. Thursday play, he just played against itself, right? And then doing all kinds of crazy things at the beginning. And slowly it improved its play. So games are nice because you have a very well-defined evaluation. Right? When you want to move this to more real-world scenarios, you have to worry about where you are going to get the evaluation signal from, but that's part of your problem design. That's part of your solution design. It's amazing, right? It's not just cycling. So if you look at babies, right? Think of how they learn to walk. All trial and error learning. It's all reinforcement learning. How they learn to talk. All the babbling that babies do, right? It's all trial and error. They're trying to learn how to control their voice box. Right? You might think that you are teaching babies to talk, but there is a trial and error phase. And they need to know how to pronounce the various phonemes. Maybe you are telling them how to sequence them together, but to get the actual phonemes out, what to say, those kinds of things, they are learning to trial and error. And so this is what reinforcement learning is. They learn to rewards and punishments, they have an evaluative feedback. And your goal is to maximize some kind of long-term performance. Not just the immediate next utterance, but learn to speak well. Right? Not just make one move, but learn to win the game. Right? So some kind of long-term performance. And the crux here is you learn through interaction. And it was actually inspired by behavioral psychology. Pretty sure many of you are familiar with the Pavlov's dog experiment, right? So that was a form of reinforcement learning, which is basically reinforcing the connection between food and the bell. So when the bell rings, so people know about Pavlov's dog? So yeah, right? So when the bell rings, the dog starts salivating because it's learned the association between the bell and food. So that is one kind of reinforcement. And from there, people have looked at all kinds of complex behavioral conditioning. And all of that is explained through some kind of reinforcement learning model. Right? So that reinforcement learning is not only very influential in AI, but also in psychology and in neuroscience. In fact, people have identified regions of the brain that are responsible for doing reinforcement learning. A lot of it happens in the basal ganglia, and some of it happens in the hippocampus. Right? So it's amazing that something that happens in psychology influences AI, and AI in turn influences neuroscience and psychology. So, and of course, it's not all about dogs, but we have real applications as well. Right? So this is reinforcement learning is one of the most popular ways of training bots. Right? Robots or other bots, right? But people use reinforcement learning a lot. In fact, one of the earliest reinforcement learning applications was to build something called Cobot. AT&T Labs built something called Cobot. Can you guess what Cobot is? Conversation bot. So Cobot. Right? So otherwise asking for smart one. So one of the earliest applications started by AT&T quite a while ago, and it was amazing. They just dropped a learning agent into a multi-user domain. Right? This is where people come in, they talk to each other, and it's no longer popular. These are called MUDs, right? Multi-user domains. They were very popular in the 90s. So when the internet was in its infancy, so to speak. Exactly. So you play with text, then you don't actually speak, you just type and then communicate with each other. And then they dropped this bot into the multi-user domain without telling people that it was a bot. Right? And then people automatically trained it, saying, hey, don't say that, that's not the right way to put it, and people are actually giving it feedback, and it learned to speak. Learned to have proper conversation. There were a few people found out that there's something unnatural about it. But then a lot of people got fooled and were actually holding conversations with the Cobot. Of course, as with many things, it will help. But so it never went into commercial production. But it's amazing. So how many of you know about the Turing test? Turing test. So Turing test, so Alan Turing is considered one of the fathers of computer science, and he came up with this idea of, now how do you say that a machine is truly intelligent or not? Right? And so his idea was that if you are not able to tell it apart in a blind test from a human, then the machine is truly intelligent. I don't care what it is using to come up with that responses. So the way he proposed it was this, right? You put a human in a room, the computer in another room, right? You don't see what is happening, and you are allowed to have conversations with both the rooms. And if you are not able to tell which room has the computer and which room has the human with a very high degree of confidence, right? Then the computer is intelligent. So that's a Turing test. So if you are able to survive in the mud, where many people think that you are another player, then you are close to getting past the Turing test, right? So they did that with the Cobot. Of course, gameplay is used a lot. It's also used a lot in things like recommendation, advertising, and customization, and all of those. I'll talk a little bit about that. But before that, there was this amazing application that this guy, Andrew Ng, when he was a PhD student, worked on. And that was at Berkeley, but this is when he moved to Stanford as faculty. That helicopter you see flying there is being controlled by a reinforcement learning agent. So, amazing stuff. It can do all kinds of crazy stunts. In fact, it can do stunts like make the helicopter fly upside down, which is a very, very unstable equilibrium that humans cannot maintain for any length of time. I can use demographics, I can use browsing history, I can use purchase history. When if I'm Amazon and recommending items, I can use purchase history, I can use locations, I can use other kinds of information I have. So the user is no longer Ravi. The user is, male, 45, with low income, blah, 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 whatever. Right? And then, of course, the actions that you have to take that features too. Right? The stories will have either politics, either sports, or items, either electronics, and so on and so forth. Right? So all of these share features. And so let us assume that each feature is represented by a set of, each user is represented by a set of features, right? And now whatever I use for choosing my actions is going to depend on these features, right? And what is it that I'm going to use? So the evaluation that I use in a reinforcement learning setting, if it's online properties, it could be clicks. I'm going to click on that, stuff like that. If in product recommendations, it could be like purchases. Do I actually go through and buy it? Right? So that is the final payoff for me, right? Could be that. Or in case of user assistance, are you really looking for this kind of bots that come up and you say accept that, right? That means you have made a successful intervention, right? So these are the kinds of feedback that you will take from the user and the user. Of course, there are some of the other things.
A little over time.
Huh? 5 more minutes? Or 5 minus 5?
According to the question answers, we have 10 minutes.
Question answers. Okay, now it's up to you. Anyway, so this is something that kickstarted the interest in reinforcement learning. Like I told you in 2006, something kickstarted the interest in using AI, right? In 2014, right, this application kickstarted interest in RL. Basically, these guys, DeepMind, learned to play video games from scratch. They were given raw screen pixels as inputs. Nothing else. Raw screen pixels as input. And they had to give out joystick commands. If you think about it, it's like mind-boggling. For us, you look at it, you immediately know, okay, that seems to be one entity, right? And then you move the joystick, the green one will move, you know how, okay, the green is what I'm controlling. And you know, you very quickly figure out what is happening in the screen because you know something about physics, you know something about dynamics. So you very quickly figure out what is happening and then you can, oh, that looks like a ball, right? As opposed to one pixel, bright pixel on the screen. But an agent that is learning from scratch knows nothing of this. Right? All it sees is a bunch of, you know, bright pixels and dark pixels and pixels of different colors. In fact, it doesn't even know what the heck it is controlling on the screen. Right? It moves the joystick. In fact, if people have played this game, all of these yellow things will move. Right? The pink thing at the top will move. So you move the joystick, you have no idea what is it that you are moving on the screen initially. Right? You have to actually even to figure that out, it takes you a while. Right? So at that point, when they got this to work with deep learning, it was considered one of the hardest learning problems solved by a computer. The hardest AI problem solved by a computer. But of course, DeepMind can rival Elon Musk at height. So every problem since then they have solved has been the hardest problem solved since then by the computer. But this was really, really amazing. But more importantly, it was reproducible. That is very important because the helicopter was a much more difficult problem than this to solve. But Andrew Ng had the only working helicopter flying reinforcement learning agent in the world. Right? So, but this one was really equally. You just needed a GPU and you can run it in your lab. And DeepMind was nice to restore. So this is amazing. So this is how it goes. So when it starts, basically it doesn't even know that it has to move after the ball. You can see that it's just not moving. And then eventually, I'm going to fast forward this because this will take too long to play. So eventually, it plays really well. And then it learns to play this other game. And then it just keeps on going, right? So there are different kinds of games that it learns to play. And then here is a graphic. Forget about what the y-axis means, right? It's some kind of normalized measure of performance. Okay, let's not go there. But look at this line here. So any game to the left of this line, the computer was playing better than humans, or at or better than human level. And anything to this side, it was below human level. So basically humans were better than computers. Right? And this was back in 2015. Right? By 2017, the line had come here. Right? So anything to this side, the computer was better than humans, and maybe there are one or two games out there where humans, and you still need humans, right? And of course, the point of the games is not to make the computers play them; it's just for fun for humans to play. So humans still have some use, but things, the boundary, the envelope is being pushed significantly. And here is the latest from DeepMind. In some sense, the current frontier for general AI, right, is something called AlphaZero. They used a very similar architecture to what played the Go game, but they made it general. So it's no longer specialized to Go, and it could play games like chess and shogi, which is a Japanese board game, right? And it's got superhuman performance in all of these, right? And they don't even bother testing it against humans anymore, right? So it played AlphaGo against the AlphaGo version that beat Lee Sedol, and it won against that 100-0. So they don't even bother playing against humans. Let's not waste humans for these things, right? And here is a quote from Vishwanathan Anand about chess playing performance. I can't see it in the editor. To watch such a strong program like Stockfish Stockfish is a standard AI against which humans play, against which most top players. Interesting. I never noticed this before, but he used who? To watch such a strong program like Stockfish, against whom most top players would be happy to win even one game out of 100, right? Being completely taken apart by Alpha Zero is certainly definitive. Right? So you don't need to play against humans, you just kind of wipe the floor with Stockfish. So, and humans find Stockfish hard to beat. It's amazing, right? Of course, I don't know how many of you know, but Demis Hassabis. Demis is the founder of DeepMind, right? And was a chess player. He was a grandmaster at 14 or something like that. So, then he got bored with chess and then went on to do neuroscience, and then got bored with neuroscience and went on to do computer science, and then founded this company. And it's like he was a multi-millionaire before he started DeepMind. And so he's like one of those once in a generational qualities, right? And he says, yeah, it's a chess. It's like chess from another dimension. Of course, he's going to say that, but still, he has the credentials to say that. And of course, people are talking about using autonomous vehicles. I'm not a huge fan of that yet. Right? I don't, especially not for the Indian context. Exactly. So there are other things that RL has been used for, right? And RL has been used in precision agriculture, right? Especially there are a couple of companies in Israel which use reinforcement learning for doing really conserve water in agriculture. RL has been used as smarter energy. In fact, it's the same AlphaGo engine which DeepMind used on Google's data centers. And then they figured out a way to save up to 30% of the energy consumption. Given that, if you look at Google data centers across the globe, they probably consume more energy than some countries. Right? So that's a huge saving. I jokingly say that RL has contributed to reducing global warming by a year. And also used a lot in intelligent tutoring systems, right? Especially to customize lesson delivery to the learning progress of students and so on. Of course, you can do this by writing rules, but reinforcement learning allows you to customize it to more fine-grained levels. So these are all things that we use this for. And that's it. It's okay, I'll stop here. Any questions? If not, I'll use a few minutes for selling myself. Open the cover, you will find this.
Like you said, the possibilities are endless, and we can interact with AI for numerous applications, including artistic ones. I would like to call upon stage Sushil Umesh, GM Apple Specialty Care, to give away a token of appreciation. I also call Rajiv Sanalkar, Group Finance Director, to give a token of appreciation from funding. When you think of it, robots are the main concern when it comes to AI posing a threat to the world. How many of you believe it's a fact? Any hands? Robots are a threat. There are few. So it in fact is a myth. Any Marvel Avengers, Marvel or Avengers fan here? I know Vedant is, and yeah, there are a couple of hands. So Jarvis, Iron Man's or Tony Stark's artificial intelligence system not only did run most of the Stark business, but also helped Avengers in their combat saving the world. It could respond to users' thoughts and emotions, and over a period of time became more of human personality with an improved sense of humor. A super intelligence without a body, just an internet connection. Good thing that it's a movie and it was on the world saving side and not a misaligned intelligence. Good morning everyone, I'll be your MC, Bhavna, for the rest of the morning. Coming to our next speaker, he is a tech evangelist with specialization in deep learning and machine learning. He has proven experience in providing compelling technology solutions to complex business problems. using a wide range of technologies. Please welcome Rajesh Patel, Architect and Program Manager, Amazon, to share how Amazon is helping enterprises in their AI journey.
I work as a solutions architect, so my job is to design solutions that go in production. So I'm the guy who's, throat is at risk if things don't work. So I'm going to talk not just about the potential of AI, but I'm also going to talk about failure scenarios. I'm also going to talk, what are the limitations of the technology, so that we have a very realistic picture of the technology. We are also going to see a lot of use cases of AI at Amazon. People are not aware about the amount of AI technology that gets used by Amazon, the number of people that are working there, there are thousands. We are going to see some AI use cases in healthcare. We are going to also see some personal stories that show the power of AI. And as you can guess, if I have to cover so many things, I'm going to talk very fast. But yeah, feel free to stop me anywhere you want, and I would be happy to take your question. So some of you are worried that one day, AI is going to become so powerful, robots are going to make us slaves, and our life is in danger. So let me tell you who is going to save us if that happens ever. So, see, these systems are very capable, but they are at the same time, if I may use the word, very dumb, okay? But whatever capabilities they have got, they are very powerful, and they are here to change our life. So I'm going to tell you all the potential as well as shortcomings of these technologies. But before that, let us start with the video. So, I'm sorry if you can't read this. So this is the overarching philosophy at Amazon when it comes to any new innovation. So in Amazon, there is a strong belief that you can't keep guessing whether a technology is going to work or not, or how much business potential you're going to have. You just have to design a small experiment and try it out. Okay? So Alexa is the result of such a small experiment. So many Amazon success stories are results of such small experiments, and that is the overarching philosophy at Amazon that many companies are trying to innovate. So out of this strategy, these are some of the success stories. That's Amazon Alexa, with a display. This is Amazon warehouse, and this stuff is being carried around by robots. These are small robots. So these are the warehouses where thousands of robots do tasks which are not nice for humans because they are very tiring. Then we are going to see story of a store, physical store where you can go and buy stuff. And this store rewards you if you are able to steal the stuff from store. This is the only store which wants you to steal stuff from the store. And then, if time permits, we are going to show this. We are going to see this video of Amazon drone delivery, which is again AI powered.
I think natural language understanding, I think machine learning in general, artificial intelligence, probably hard to overstate how big of an impact it's going to have on society over the next 20 years.
The vehicle is completely autonomous. It lands by itself, it navigates by itself, it can fly more than 50 miles an hour, it has a 20-mile range.
We're really just beginning in robotics. It is the birth of robotics right now. We use our machines at Amazon so that we can have a more efficient fulfillment process. Ultimately, it's about humans and machines collaborating together in order to achieve a meaningful task.
Alexa, add anniversary to my calendar.
Alexa, accept the call. Hey, Mom.
Alexa, play my relaxing playlist.
Alexa, turn off the lights.
Okay.
So with Amazon AI, we're bringing the power of deep learning and advanced machine learning to all developers so that they can bake intelligence inside the heart of every application and inside the heart of every business.
Recognition
allows you to pass an image to us, and we will detect objects in the image. We'll be able to tell you that there's a person in this image, or it's a woman in this image, or it's a car.
With A9, we're completely reimagining what it means to search. From landmarks to books, visual search enriches the world around you with contextual information powered by artificial intelligence.
Today, we don't have any if conversation. Every conversation is a when and how conversation. This is a world that I want to live in.
So, we see how Amazon is innovating with the help of AI, but I want to put a number on how valuable this technology can be. So let me cite this statistic to you. So every third purchase that you do on Amazon.com is a result of recommendations powered by AI. Every third purchase. Amazon's revenue last year was $170 billion. Just do that math for yourself. Every third purchase. Okay. So that is the value of technology for Amazon, and same is going to be value of that technology for most enterprises around the world, including yourself. So let me just define these terminologies for the context of this session. So everywhere we are not using our intelligence but machine's intelligence, that would be referred to as artificial intelligence. Artificial intelligence can be designed by hand, but you can also potentially let machines learn by themselves. So that is machine learning. And a recent, or rather the most hyped up trends in this field are created by a technology called as deep learning. So in deep learning, we try to emulate human brain to some extent by designing models with the help of what is known as neurons. So most of the hype around this field has been created because of successes in deep learning, whether it is computer vision, whether it is reinforcement learning, or whether it is natural language processing. So a lot of applications that we are going to discuss today are going to be of deep learning technology. So I want all of you to take a look at this image and tell me whether the person in this image is an old woman, is that a middle-aged woman, or is that a small girl? Say it out loud. Small girl. Oh, why do you think she's a small girl? Height. Yeah, but old women can also have ponytails. And they can also wear frocks. Okay? So have you seen those stuffed elephants, baby elephants you can buy in toy stores? They are elephants, but they look like babies. There is a common trick that is used by artists as well as designers of those toys. Okay? So if you see proportions of her body, what is the size of the head relative to the rest of her body? It's quite big, right? So human babies or babies of animals on an average tend to have their heads which are larger in size compared to adults. So adult head is like 12% to 15% of body size, whereas baby's head can be as much as 30% of body size. Did we know this? Did we know this? Our brain knows it internally. Okay, that's how we are able to tell babies apart from adults. But did we consciously know this? Okay, so this is a pattern that machine learning can pick it up for you. So these are the kind of things they're able to see that we fail to see consciously. So let us quickly look at the kind of things that deep learning can do for you. So it can do two broad classes of things. One is classification and second is sequence-to-sequence processing. Reinforcement learning and other sorts of things are emerging areas of it, and they are developing very rapidly. But most industrial applications today, they fall into two categories. One is classification and second is sequence-to-sequence processing. Examples of classifications are object detection, face matching, right? Telling if a medicine is fake, looking at CT scan and telling whether that tumor that you see in that medical image is cancerous or not. So these are the kind of things which are done with help of classification. Sequence-to-sequence processing gives us technologies like automatic speech recognition, like you see in Amazon Alexa, natural language understanding, like you see in Amazon Lex chatbots, translation, you can see it in many translation apps, time series predictions, these are the technologies that predict when a vehicle is going to break down, when a machine is going to break down and things like that. And last but not least, sequence classification. So this class of application can tell you, for example, whether the heartbeat pattern is normal or not. So these are the kind of industrial applications that are there today, and they fall in these two broad categories, classification and sequence-to-sequence processing. So let us take a quick look at some of the applications. So how many people are familiar with this company, Veripack? Okay, so they have developed applications to tell fake medicines apart from real medicines. So we are going to see a very quick video of it. Unfortunately, it doesn't have an audio. Sorry about that. So you make powder out of the medicine, and then you do this strip, you put it on it. It develops some color bands, and based on the color of those bands, you can tell whether it's real medicine or fake medicine. But again, you don't have to be an expert. You can take picture of that strip, and AI or deep learning based models can tell you whether it's real medicine or fake medicine. So it's done on AWS. The next one is there is this company Lung Direct. So they can look at medical imagery, and they can talk about, or they can tell you the malignancy risk that is there based on what their models see in the images. The accuracy is pretty high, and it is catching up real fast with human doctors. Although it lags human doctors a little bit, the competition is not really with human doctors. Okay, the competition is not with 80% accuracy. The competition is with 0% accuracy. Places where there are no doctors at all. Then this very smart company, HeartFlow, they are using deep learning models to look at medical imagery and build 3D models of heart and to visualize the blood flow that can tell you exactly where the blockages are, without doing the traditional kind of tests. So many other applications in the area of radiology. Again, this is cardiac visualization by one more company that we just saw previously. There is this company, so far the examples that we saw were mainly of classification technologies, image classification. This company, Canary Spidget, falls in the second category of technologies. They use sequence-to-sequence processing to study, vocal tremors, slower speech, and gap between words. With help of that information, they are able to tell whether there is a brain damage as a result of some accident or as a result of some brain condition. So these are some of the interesting use cases that have been developed on AWS by AWS customers. Now, what deep learning cannot do? Okay, so when people imagine AI or deep learning gone rogue, they imagine a Skynet kind of intelligent agent manipulating things. So rest assured, because deep learning cannot do reasoning. It can do classification, and in many cases, as Professor discussed, the classification accuracy is much better than human classification accuracy. Okay, it can do sequence-to-sequence processing, right? As for language, translation, and things like that. Okay, but it cannot do reasoning.
But may not be today. Tomorrow they will do.
Tomorrow there might be a meteoroid that will strike Earth and will destroy Earth, and then we have no reason to worry. I'm sorry. What I mean to say is, first of all, reasoning. So much effort has been put behind that, but it is an enormously complex area, right? We don't know whether we are going to be able to find a solution to that in this century or next, or maybe 1,000 years down the line. Okay, so there can be so many things that we should be afraid of technically, but if the risks are 0.00001%, probably we can focus our attention on other things.
Just a question here.
Yeah.
We are talking about artificial intelligence. So what do you mean by reasoning?
So reasoning is, for example, reasoning involves making unseen connections, inferring things. Okay? So these are the kind of things that are there in human reasoning. So for example, if somebody hires me to be an architect in their company, okay, I'm not doing classifications or I'm not doing much sequence to sequence processing. What I am doing is I'm talking to the customer, I'm seeing what is the problem, I'm looking at all the technologies that are available, then we are designing the solution, then we are trying to foresee what could be the failure scenarios. There are going to be times when we are not going to be able to see with much accuracy what is going to happen. So we design an experiment. So there is a lot of thought process that is required to be given in this process. So these are the kind of things that AI is not at all capable of doing at current stage of evolution. Okay, so there are things like automated reasoning and all, which try to solve some mathematical theorems, but these kind of technologies work in a very well-defined environment. Okay, so AI, as people believe, is not going to replace lots of jobs. Some jobs it is going to make easier, it is going to assist humans, but I don't see any large-scale, job loss happening because of AI, because it can't do reasoning. Now, how Amazon uses AI, we have seen a video, but let me quickly recount the things one more time. So, as I told you, every third purchase on Amazon is, result of a recommendation by the help of AI. So that's huge revenue for Amazon. Then Amazon's fulfillment centers are powered by robots, and these robots come in various sizes and shapes. One of the reasons fulfillment centers have robots is because that job is not suitable for humans. We are going to discuss that. Then drones. There are a lot of regulatory challenges in deploying drones, but that hasn't stopped Amazon from investing heavily in the research, because sooner or later regulation is going to accommodate drones. Voice-driven interactions. Nobody had imagined how much successful Alexa is going to be, but it is now coming up as the next operating system, the way we have Android and iPhone. Then the last example is of Amazon Go. How many of you know Amazon Go? So very few people here know Amazon Go. So that's a store that rewards you and thanks you if you're able to steal stuff from there. So we are going to see a video on Amazon Go very soon. So let me zoom in on some of these examples. So visual search is one area where a lot of AI is being now implemented. If you are trying to search for a book, you can type the name of the book. So typing is much easier when you are searching for a book. But when you are trying to search for a fashion accessory, okay, when you are looking for a particular type of gown or particular type of jacket, it is very difficult to describe it in words. From some magazine or from somewhere where you saw it first and you upload it, the system can find out the gowns or jackets which are matching that jacket. You don't have to describe it in words, because every time we cannot sufficiently describe things in words. So visual search is a very upcoming area, and I'm going to show you one demo of visual search. I'm going to show you how easy it is to develop a visual search engine. You can develop it in 1 hour by yourself. Then Amazon Robotics, there is a company called as Amazon Robotics owned by Amazon. They develop all these robots. So what used to happen is human beings who used to work in Amazon warehouses are massive, and you can order a candy box, a toy, an iPhone and a book. Okay, it would be very efficient if all these things go in a single shipment because shipments are expensive. But if you want to send them in a single shipment, okay, the picker who is going to pick those items, the human being, he needs to walk a lot within warehouses. And what was happening is human pickers had to walk close to 30 kilometers in a single day within the warehouse. It is inhuman. Okay. So now these robots, what they do is they lift the entire rack which has got that item and they bring it to the packaging station. And this task is not trivial because if you are packing a box for me and if I order 4 items, for logistics reasons, the 4 robots bringing 4 items need to arrive all at the same time at that station. They can't arrive out of order. Okay, so it's a massive problem of logistics, not just robotics. Okay, so Amazon has made great strides in it, and there are a lot of robots, in fact thousands of them working in warehouses. Then Amazon has tried to improve experience everywhere with AI, not just visual search. So this is a feature called as X-Ray from Amazon Prime Video. How many of you have used Prime Video? Thanks. So yeah, in Prime Video, if you want to know more information about a scene, just move your cursor on the screen. It will immediately tell you who are the persons or the actors in that scene. And for many shows, it will also tell you about some trivia about that particular scene. What happened when that particular scene was being shot and all. So all this information is being tagged into the videos automatically. And these solutions Amazon has made available for AWS customers as well. Next one is Alexa. So Alexa is on its way to become the ubiquitous voice operating system. You can do so many things with Alexa. So I was one of the first Alexa users. I got Alexa like 3.5 years back, almost when the beta program was announced. And I'm having that Alexa at home. And although I work for Amazon and I am privy to a lot of discussions, I myself could not see potential of this technology back then. I really failed to see potential of this technology. But now you see people are doing so many things with Alexa. A lot of electronics gadget makers, they are building their gadgets to be compatible with Alexa so that you can control them with Alexa. A lot of car manufacturers are going to put Alexa in their cars. You can call an Ola and Uber and order from Domino's using Alexa. The thing is, the reason Alexa is so successful is because it is very easy to use. And second is because there are a lot of things which are very repetitive that we do. Okay? What I mean by that is we call an Uber every day when we are here for office. Or if we are ordering some food items, generally we tend to order same items again and again and again. So Alexa is really good for all these type of scenarios. Why Alexa was designed? Like one of the motivations behind Alexa. Yeah. That's true. So one of the motivations behind Alexa was if you go to any e-commerce website, right? Website 1, website 2, website 3, all have decently well delivery process, right? A jacket is being sold for 3,100 on one website, 3,050 on another website, and 3,040 on third website. Where you will buy it from? Sorry? Yeah, but the difference is just of $60, which is not even like 3-4%. But you are changing to another service provider just for that 3-4%, which makes sense. All you have to do is just change the tab on your browser, right? So the problem is if everybody starts ordering via browsers, it is very difficult to retain the customers because you don't give much better experience to the customer. But with Alexa being used for ordering from Amazon Prime, it is far better experience compared to opening up a browser and going there to place order for some eggs or Surf Excel. right? Just say, hey, Alexa, ask Amazon Prime to deliver some stuff. That's all. Then it is expanding to a lot of more categories. I will show a video later on. Now these devices come with displays. You can ask it to call your mom or whoever. These devices, the previous one particularly, it also gives you fashion advice. Right? You wear something, and it will tell you whether you are wearing it as per the trend or you are out of trend. Those kind of things. So the possibilities are infinite. So this is Amazon Go. Okay. So while Amazon has grown big and all that, and it is able to serve customers with millions of products, there is still a large chunk of retail that happens in physical stores. Physical stores are never going to go away. They are going to be there, okay, because they are very convenient. So Amazon has this ambition to be in the physical store space as well. But Amazon thought how we can redefine the experience for the customers. So what is the single most thing that you hate when you go to a hyper city on a Sunday evening or a Saturday evening? Long queue. Exactly.
Years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store, so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So, how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go. No lines, no checkout. No, seriously.
So this Go store is in Seattle. If you go to Seattle, definitely go there. You have to be a Prime customer for that. It has become a tourist spot in Seattle. Most people, they don't want to miss a visit to this store. And if you steal anything, it is yours to keep. Okay, no one is going to ask you about it. And in fact, if you report to Amazon that you were able to steal something, you will get a thank you note from Amazon. Because you gave Amazon a test case where it didn't work as it should have, so that it can be improved. But I would also like to point out to you that it rarely fails. Now coming back to drones, so these drones are powered with a lot of technologies like GPS and all, but most importantly they heavily use computer vision. These drones are designed to be extremely safe, because when they land at a place near your house, if a dog jumps on it, you don't want the dog to be hurt and things like that. So these drones have a lot of research that have gone behind their design. They also avoid collision because they can see things as well as they can radio sense things. So yeah, this is another area where Amazon has very successfully used AI. So this is one of the nicest quote I like about AI, that future is here, it is not just evenly distributed. Okay, So there is this very impressive, very capable technology, and I see that so many companies are yet to realize the potential of this technology. They read about it, they talk about it, but they are not serious about it. They haven't set aside human resources or money for it. The thing that is done in Amazon, there is a certain amount of money and human resources that is set aside for experiment. A lot of experiments are tried out. Some of them succeed, some of them fail. But the upside of that model is extremely high. And unfortunately, like I personally don't see a lot of people or a lot of companies trying out that model. So it is highly recommended. Everywhere I go, I suggest that model. Now, we have seen the potential of this technology. So let us see what are the rough edges of this technology. Okay. So let us take one example from natural language understanding. So this was a statement in English. The spirit is willing, but the flesh is weak. Okay. It was translated using a translation engine to Russian. It is again converted back into English. This is how it got translated. Vodka is good, but meat is vodka. Okay. This is long back. The translator in today's time, they don't make a mistake like this. But I'm just trying to show you how difficult language translation problems can be. So recently I had a 2-week trip to China, and it was far more adventurous than I imagined, particularly so because of the language problem. I have been to South America, I have been to Korea and many other highly non-English speaking countries, but the kind of problems I faced in China, nowhere else I faced them. Okay, like that if you have got Google Maps and some of your apps, you are fine anywhere you go in the world. In China, they don't have Google Maps, it is blocked. They have Baidu Maps. Baidu Maps is far superior or more advanced than Google Maps, in my personal opinion. The only problem is it looks like this. Okay. So I was like completely lost in that country. The only reason I managed to navigate in that country by myself was because I had a very good translation app with me. Okay, so this technology has come of age. There are some rough edges, but it works pretty well, and it did a lot of productive work for me. And this technology, as I said, like far from perfect, but close enough to give good results. And it requires constant improvement. Okay, so there is this approach called as active learning, where you have human in the loop. So if the model didn't work, okay, those things are very quickly highlighted, and in the next iteration of model building, those things are fixed. I'll give you one example. So a lot of chatbot companies these days, not a lot of, but very few of them which have been successful, what they are trying to do is, like when a customer is talking to the chatbot, okay, if at some point the customer starts repeating himself because the bot is not able to understand, those kind of scenarios are detected. If the customer is angry, if he uses a cuss word, or he asks the bot, are you dumb, whatever, right? And immediately that conversation is handed over to a human agent. The human agent takes over, and again he or she hands it over to the bot. So there is a human in the loop, and in the next iteration of the bot, that conversation is used as a training sample to improve it. Okay, so that is how this technology is maturing by each passing day. Then the next case is adversarial example. So while deep learning models work, we don't know how they are able to work fully. To some extent we know, but we still don't know. So this is a technology. We can build models, but we can't explain how these models work. So I'll give you an example, right? A quadratic equation. It has got two variables. Quadratic equation, right? We can understand behavior of a quadratic equation because it has got just two variables. maybe we can understand behavior of an equation which has about 10 variables, okay? But as Professor said, like AlexNet has like 6 million parameters. It is 6 million, right? So yeah, so there are like 6 million variables. We are not able to comprehend how 6 million variables interact with one another. So while we are able to build the models, we don't understand their internal behavior. And this is the reason, there is so much fear about it. These models work, but we don't know how they work. So I'll give you one example. So this is an image of a panda, and ImageNet quickly tells that it's a panda. But if some noise is added to the image, it is identifying that image as that of a gibbon. Okay? Why this happened? We can't explain. So there is a way to build a model which is robust against these kind of adversarial examples, but you can only go so far. Okay? The point I'm trying to make is, at one level this technology is very fragile. The only good thing is, coming up with that noise is very difficult. That will fool the image. But the point is, there is some fragility in this technology. The next one is about costly errors. So this is image that was published by Arizona police when Uber self-driving car hit a pedestrian. Unfortunately, that person was killed in the accident. Okay, very sad. So this is anatomy of a self-driving car. It has got so many sensors and things like that. And despite that, that accident happened. Okay. So there are a lot of investigation behind it, and I don't want to speculate exactly what went wrong, because that is for one enforcement agency to determine. But this is the thing that you have to remember, that you have to choose thresholds properly. What I mean by threshold is confidence level. Okay. So it seems that in this case, what happened is the image classification model that interpreted that person that was in front of it as a plastic bag which was floating in the air. Okay, and it just drove through it. Okay, so the thresholds have to be set very high. There is another example. Recently, the police in USA was using facial recognition technology to tell whether some migrants are criminals or not, and they set the thresholds very low. So the accuracy threshold. So what was happening is, very easily they were matching images of certain migrants with fugitive criminals, and these people were branded as criminals and they were deported. Okay. One set of researchers, what they did is, they used the same accuracy thresholds and they took pictures of senators of United States and they matched it with criminal database. For 80% of the senators, they were able to match them with at least one fugitive criminal. Okay. Sorry? Yeah, they will match 100%. Okay. So what was going wrong is that the threshold of accuracy was set very low. So if you set the threshold of accuracy at 95% or 99%, there are hardly any false positives. But at a level of 80%, there were a lot of false positives. Okay. So that is one thing that you have to keep in mind. Secondly, you have to combine outputs of multiple independent systems to arrive at a decision. Okay. So in this self-driving car or in any typical self-driving car, you have cameras, you have LiDARs which use laser to map the space around them, and then you have radars which use radio waves to map space around them. Apparently what happened in this case, again I don't have full knowledge of it, this is based on media reports, is that radars were turned off. Okay, so there were fewer sensors trying to sense environment. So see, typically if computer vision failed, at least radars won't fail, right? But radars were turned off. Okay, so you should typically have multiple independent decision-making systems that work together to arrive at a final decision. The next one is lack of explainability. So while these models work, we don't know how they perceive the world. So how a coffee cup looks like. We can imagine how a coffee cup looks like. So some researchers took a very popular computer vision model. They reverse engineered it using a class of techniques called as agentic algorithms. And the model showed researchers that this is how it imagines a coffee. Okay, so the model thought a coffee cup is always with hands surrounded with it. The reason for that is a lot of training images that were used in training that model were having coffee cup in some or the other hand. The models themselves will be biased. Okay, so this case happened. I don't know how many of you are able to see from behind. So there is this photo app which tags photos automatically and groups them together. So the photos tag these people as gorillas. Okay, yeah, we can laugh at it, but for people for whom it is happening, it's very insulting. So what was happening is people tag their images by hand, and there are some racist people who probably tag black people as gorillas, and that data was used without any filtration for model training. So model learned to classify black people as gorillas. So sad, right? So you can't have an unbiased model if you don't have unbiased training data set. So you have to clean your data set very cautiously. The next one is regulatory challenges. So Europe is at the forefront when it comes to safeguarding privacy of the citizens, as well as a lot of European laws are very strong, trying to safeguard the interests of racial minorities. So they obviously conflict with deep learning technologies. So this was a tweet by Pedro Domingos. This was his interpretation, and still many people's interpretation, that as per the GDPR laws, deep learning is going to be illegal because you can't explain how a model is going to work. Okay? So far, no action has been taken by government agencies on the companies that employ deep learning, but deep learning technology does not pass the muster of GDPR regulation. While it is a superb technology, it's very productive. It stands in conflict with this regulation. The next one is privacy concern. Okay, so a lot of companies have this culture of open office space. Everybody can see everybody else, except for some top bosses who get cabins with glass walls, so that even what they do is not hidden from other people in the company. You can clearly see who went inside the cabin for any meeting. Every company needs some privacy, so typically those cabins have got doors, so you can't eavesdrop on that conversation. And it used to provide pretty good privacy to the senior executives because that is very important to conduct business at times. But that model is not going to work anymore. Okay. So I'm going to show you example of a model called as DeepNet. So yeah, if you just have a video feed, you have a high zoom camera, just zoom in on the lips, you are able to tell what that person is speaking. The next one is something that frustrates everybody in this field: lack of predictable success. Okay. So this picture is of a person who is trying to perform alchemy, trying to find a chemical that can convert iron into coal. He is one of the most famous scientists who tried to be an alchemist and died because of it.
Marie Curie.
No, Marie Curie never tried to be an alchemist. She was part of it. Okay, so you'll be shocked. Yeah.
Well,
I'm sorry. Okay, so see, the thing is, in past, people or the most intelligent people from that era thought that alchemy did actually exist, and they tried to figure out the secrets of it. One of the persons trying to do was Newton, and then there is a theory that while trying to figure out alchemy, he used some chemicals which were poisonous to him, and he died because of it. Okay. That is theory, not 100% proven yet, but yeah, it is very well established that he dabbed in alchemy. So there is this news item: a small student of AI coders beats Google's machine learning code. Okay, And that is not just with Google's code. Take topmost AI scientists from any company, many a times their results have been exceeded in terms of quality by very young people still studying in colleges, because this field hasn't reached the maturity of engineering. In engineering, if you want to design a mall in a certain space with certain constraints, you can definitely design it. Okay? The design is going to be accurate in 90% of the cases. In deep learning, this hasn't reached the level of engineering, so you don't know what kind of model is going to give you best results. So people do a lot of experimentation in this field. The next one is systems producing desired effects in undesired ways. Okay. So what I mean by this is one of the video streaming companies, they used reinforcement learning to recommend videos to their users. Right? This is what Netflix does, Prime does, everybody does. I will not cite which customer did it. But what happened is they gave a metric to this model to improve, which was the average viewership, average number of minutes each person spent on that site. And this model was able to improve that number phenomenally well. But you know what that model did? It actually frustrated the users who were using the site for lesser time. Okay, those users dropped off. So the people who were left behind, they were using it a lot, and automatically the average went up. So although the result was achieved, it was achieved in a very undesirable way. The next one is visual search that you see on Pinterest or Amazon. I have that model running, but again I will skip it for consideration of time. So this model was designed by one scientist with free data set of millions of images in just one thing. Okay. Again, that is not original work. He tried to emulate what Amazon.com did or Pinterest did. But the point I'm trying to make it is it was done by this one person. So phenomenal results can be achieved by individuals in this field. Next area is rising over the horizon. So these are the technologies that are relatively yet to mature. So one is generative adversarial network. So in one way of thinking, these models are able to understand concepts and they are able to do maths with concepts. So if you take a man with a goggle and subtract a man from it, what you are left is with a pair of glasses. And if you add a woman to it, what you get is woman wearing glasses. Okay? So basically these models are able to understand concepts like a man, woman, goggle to some extent, and they are able to play with that. So various versions of this technology are in production today. So there is a version called as Superfine. You can take blurred images and make blurred images very sharp because it is able to understand what is inside the image and it is able to add extra details to that image. This is my favorite example. You know, in this picture you are able to convert horses to zebras and zebras to horses. You are able to do image editing using deep learning. That guy ran it on a video clip. It did it pretty well. It made only one mistake. Can you tell what is the mistake? It even painted stripes on the tail. Zebra doesn't have stripes on the tail. But you know, this is technology at this stage. Imagine what it would be like 10 years down the line. Next one is reinforcement learning. As Professor told, these models are able to figure out strategies on their own. So this is one quick example. It is able to solve Rubik's Cube in 0.7 seconds. It actually figures out a solution in milliseconds. It is that mechanical movement it takes 0.7 seconds. Next one is AI at the edge. So this is how a deep learning model looks like. It has got a lot of connections. People have figured out that even if you break a lot of these connections, the model accuracy doesn't go down as much. And it has allowed us to build models that work even on mobile phones. So because of that, you have applications like these. These are offline translators. That girl is having those Snapchat filters on a picture. I don't know why people love them as much, but yeah, keep in mind that these filters are the result of AI-based technology. Amazon has gone one step further. AWS has released this camera. These are AI-powered cameras. They can be customized for your use cases. So you can have a camera, you know, when you drive to your home, when it looks like it's your car, if you open the garage door for it, you don't have to come out of the car. People are putting these cameras on construction sites. If anyone removes the helmet, it points out who removed it and it warns instantaneously. AI plus IoT, even a much smarter world. So this is a picture of Amazon camera and a smart key that is synced with that camera. How you can use this pair of technology? You can allow delivery people from Amazon to do deliveries at your work even when you are not at home. The key will activate only when the person reaches there. Okay, and you can see what that person is doing inside your house, and that's how you can have deliveries even when no one is at home. What is better than this, right? So in US, most people live in suburbs. They come to cities in cars to their work. So if you go and do deliveries in suburbs, it is very expensive because suburbs are not densely populated, right? It is much easier and cheaper to do deliveries in cities. How about if you could deliver stuff in terms of their cars? Okay, so Amazon has this delivery model. You park your car anywhere in the city. Amazon will locate that car, go there. Okay, the trunk opens only when the guy is there. He puts the stuff, closes the trunk, and goes away. So this solves, a logistics problem to a great extent. So Amazon has developed all these technologies, and a lot of technologies have been developed by scientists around the world. Our job is at AWS to make all these technologies accessible to customers like you. So there are a lot of technologies, but we don't have time to talk about these specific technologies. We can talk in detail later on. Amazon also has a lot of research grants. We sponsor universities to conduct research. Then apart from that, Amazon has this model called as ML Lab, and it is something that you should take out as a takeaway from this session. That Amazon has thousands of people working in machine learning and AI, and their expertise are available for you. Okay, so Amazon makes internal scientists and engineers available to customers like you if you have projects that you think are going to benefit from it. There are a lot of ML Lab customers. There are a lot of Amazon partners which have developed technologies on top of AWS Cloud to solve a lot of use cases using AI. Okay, so these are some of the customers. In fact, you see all the famous names there who are doing their AI work on top of Amazon. So let me end with a quick personal story. So on website, that's me. I used to weigh 92 kgs. This is me. Just a couple of weeks, I weighed 70 kg. Okay, I lost 22 kgs of weight in just a span of 6 months. Okay. If somebody would have asked me when I was back how much I would pay to lose 22 kg weight, I would have said, take my year's salary. It's totally worth it. Okay? But I didn't have to pay my year's salary. All I had to do was to buy this gadget which cost me 10,000 rupees. Okay? So this gadget uses AI to study your motion, to study your calorie consumption. And I set a simple goal that my typical calorie burning is 2400 calories a day. I should not eat more than 1,000 or 1,200 calories a day. I set a daily goal, not a 6-month long goal. And I stuck to that goal, and I lost almost at the rate of 4 kgs a month. Okay. All I had to invest was 10,000 rupees for this device. Okay. And I didn't have to pay my year's salary. Okay. So this device is powered by AI. It analyzes your motion, your calorie consumption, a lot of things based on AI. Okay? So that is how valuable this technology is. And I want to give you one last example, again from your domain. So last December, on the day of Christmas, my uncle passed away. He got a heart attack. Okay? Nobody in our family realized that he was having a heart attack, and everyone was at home. Okay? He was just feeling uneasy and he was coughing when he used to sleep, and when he used to sit, he used to feel better. Okay? Everyone thought it is some kind of viral infection that he has got, and that's why he's coughing. but what he was having was a slow heart attack. Okay? Heart attack does not always come like they show in the movie, where you have a sharp pain and the person dies. There are many heart attacks which are very slow, they progress very slowly. So he was having heart attack for 2 or 3 hours, and we didn't realize it, and he died. Okay, it's extremely sad. Okay, and so many people die like that. Okay, but that did not happen going forward, because now we have technology that can tell us if you are getting a heart attack in real time. In fact, it can start alerting you as your symptoms start showing. So there is this bunch of Stanford graduates. They have developed models that can run inside your smartwatch that can detect what kind of heart ailment you have. Not just that, they can indicate to you if it is worsening. Okay, and Apple has put that technology in their latest version of smartwatch, and you can rest assured that it is going to come in all the smartwatches in the next time. So that technology is going to solve millions of things. So that is why we should take this technology seriously, and we should see how we can put it to use in our companies and in our daily life. Thank you very much.
Any questions?
Thank you.